My name is Linley Gwennap. I'm the principal analyst of the Linley Group and also the editor-in-chief at Microprocessor Report. So I want to shift gears now and talk specifically about some of the products that we're seeing for use in data centers to accelerate AI. In the data center, the companies that have been having the most success are Nvidia and Intel. Initially, a lot of the AI work was done on Intel CPUs. Now, we're seeing a shift to GPUs, which have more floating point performance capability. Particularly, NVIDIA's V100 is the most popular solution today for training neural networks. And what NVIDIA has done here is they've actually added these things called tensor cores, which are very small systolic arrays, to their GPU architecture. So they're adopting the traditional GPU architecture with these tensor cores to deliver very high performance, over 100 teraflops in a single chip. And so that is a lot more than you can get out of a CPU. For inference, people still like to use some of the Intel CPUs, and so Intel has added some capabilities in the most recent Cascade Lake model to triple the AI performance relative to the previous generation. But you're still looking at like 18 teraops versus the kind of 100 teraflops in the NVIDIA. So NVIDIA's brought out a product called Turing. Specifically this T4 card that they're positioning more for inference, and that card in the integer mode provides 80 teraops as compared to the Intel processor at much lower power. So that we're seeing a shift toward GPU for inference as well as for training. But we're starting to see some new companies getting into this market. It's grown to be a pretty good size, about $4 billion last year, and that's starting to attract interest from other companies. Small companies like Habana. Habana has a product called Goya that provides excellent performance on things like ResNet 50 and better than what NVIDIA or Intel is offering. Xilinx, of course, the FPGA supplier, has introduced a card called Alveo, and what they've basically done is taken the FPGA, they pre-programmed it to execute neural networks efficiently, and they've also demonstrated on certain conditions performance that is better than what NVIDIA is offering with their T4 card. Intel, in addition to their CPUs, wants to offer a more efficient architecture. So they've created a product called Spring Hill that is supposed to ship this quarter. And some of the initial benchmarks on that product look very promising as well in terms of much greater power efficiency than the NVIDIA T4 for inference operations. And Wave Computing has developed a chip that's optimized for inference as well. They're planning to bring that out in systems and also license the IP. So we're seeing more companies here, both large companies and small, in the inference market. On the training side, there's been a little less products available today, but we're starting to see things that are coming out very soon. Habana, as I mentioned earlier, has an inference chip, but they are also working on a training chip that should be out next year. Intel has a chip called Spring Crest that is different from Spring Hill. Spring Crest targets the training market as well, but they haven't shown us any performance numbers on that. Huawei just introduced a product based on an in-house ASIC that they've developed that looks very good in terms of total operations, teraflops, and teraflops per watt. On some of the initial neural network benchmarks are more similar to what NVIDIA is offering, but that looks like a promising product as well. Cerberus is a small company, but you may have heard they introduced the largest chip ever built about a couple months ago. And so this chip is designed for very large models that they can run entirely on this piece of silicon and create greater efficiency. Graphcore is another startup that has this chip with over 1,000 cores that they're positioning for training as well. So lots of activity going on. Still haven't seen benchmarks on a lot of these products, but I think we're starting to see some good competition emerge in this data center training market. We're also seeing additional competition from the cloud vendors themselves. Many of them are now developing their own in-house products. Google, of course, was the first with the TPU a few years ago. They've now brought out their third generation TPU for both inference and training on the different TPU chips. Microsoft has deployed an FPGA-based product called Brainwave that they're using for AI inference, in particular for parts of their Bing search engine and some of their other in-house services. Alibaba recently announced a new ASIC that they've designed that they're deploying in-house for search and recommendation functions. Amazon has talked about a chip called Inferentia that is supposed to be out by the end of the year, but not a lot of details there yet. Baidu also has an ASIC that they've talked about that they're using for AI. So, we see these cloud vendors that understand their own workloads very well. They understand the AI functions that those chips need to execute, and they're able to design their own ASICs that are optimized specifically for the workloads that they want to do. And they see this opportunity where some of the third-party products are late to market, that now they can develop their own chips and use them in-house. So, I've mentioned some performance numbers, but it's really difficult today to compare the performance of these AI accelerators. You can talk about teraflops and teraops, but that really is just the peak performance, the maximum that a chip can do. The real question is, how close is that chip getting to its peak performance when it's actually running a neural network? And so you would say, okay, well, let's just pick a neural network that we can all agree on. Let's run that neural network on all the chips, and we can compare the performance. Well, that's a good start. So, of course, you can't compare the numbers on training and the numbers on inference against each other. So some people get confused about that. The training is obviously more complicated, so it runs slower, even if it's the same neural network. So, you have to separate out those scores. ResNet 50 is kind of the most popular benchmark that people use. It's kind of a relatively simple network compared to what most companies are using in production today. But at least it gives us some idea of what's going on. But there's another factor that's important here, which is the batch size. What that means is that in a lot of cases, in order to take advantage of all the parallelism in these devices that may have hundreds or thousands of cores, that you can take several, again, if you're talking about cat photos, you can take dozens of photos and feed them into the accelerator at the same time, and then process those in parallel to take advantage of all the hardware. And naturally, you're going to get the most efficient use of the hardware in that scenario. But what if you have a service where you need a response as quickly as possible? So in that case, you want to feed one item in at a time so you can get a response very quickly. And that would be a batch size of 1. So what this chart shows is the performance of two products. One of them, the green line, is NVIDIA's Tesla T4 card. And you can see that the performance at batch size of 1 is around 1,000 images per second. But as you increase the batch size, you can put more images in parallel. The performance goes up considerably until it reaches about 4,000 images per second at a batch size of about 16. And you can also see, however, I put some millisecond numbers on there, which is the latency or the time it takes to compute. And you get the best latency, about 1 millisecond, when you have batch size of 1, which is why people would use batch size of 1. And if you start trying to maximize the throughput, now your latency goes up to as much as 7 milliseconds. But if you look at the second product, the Habana Goya, which is the red line, you see a similar curve, but the difference is not as great. So between batch size of 1 and batch size of 16, Habana's performance changes by about a factor of 2. So it really depends on what part of the curve you look at. If you're Habana, you want to say, hey, we're 4 times better at batch size of 1. If you're Nvidia, you want to focus on larger batch sizes because that makes Nvidia look better. So, and you certainly don't want to compare batch size of 1 on one processor to batch size of 16 on another processor. So you have to make sure all of these variables line up if you want to get a fair comparison in performance. And then, of course, you want to consider how much power each chip is using. You want to consider how much they cost. And so it becomes a complicated process.